again, this is ARTEMIS Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LMS, or a loss of signal with us on Earth, as they'll be flying behind the moon. As the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the ARTEMIS Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for ARTEMIS 2.
Sure. So I'm the ARTEMIS Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology, and also it is part of our Earth-Moon system. And the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young, but on the moon we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an ARTEMIS mission?
Yeah, it's pretty exciting for us as we have really sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon, and we have a live view here of the science operation, or the science evaluation room. So this is where the majority of your team is today, is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them, and they're now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down, and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we are all we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment, and I think everybody's just really excited to see. You know, even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon come through.
Yes, we are in for a real treat today. It's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future. From everything from, you know, how do you train a crew to be a geologist, right? And so, you know, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing the software that the teams are using, and then, you know, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community.
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration, and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists, because we are the ones who are the experts in, you know, landing site and doing analysis of landing site and making sure we can find a good place to land, to like understanding the properties of the soil so we can, you know, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, you know, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now getting closer and closer to our lunar neighbor. This live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
individual cards. Victor's 1008, Jeremy 1019, Reed 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2. And Earth out window 4 and Moon out window 3. And it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed. Those are some of the communications we're excited most about today. Commander Reed Wiseman calling down their view right now. Obviously a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Cook calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start in just about 20 minutes. Checking in on Orion's distance and speed, they are currently traveling 1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the Moon, and continuing to grow closer. At closest approach to the Moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the Moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The lunar geography review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby, because
Of course, the moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package, and a screenshot specifically of that lunar.
Go ahead.
Hey Jenny, understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Cook, NASA astronaut and mission specialist on ARTEMIS 2.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
Houston, integrity for timeline.
Good.
Hey Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to start some observations in about 13 minutes.
Copy. Thanks, Christina.
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
The conversation you hear happening now between the astronauts aboard Orion and ARTEMIS Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut, and Artemis II backup. She was also the lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are into dead bands. Dead bands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is ARTEMIS Mission Control. We are standing by for the beginning of lunar flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them. and just minutes away from the official start of lunar flyby, or when it is timelined for the crew. We are currently 10,726 miles away from the moon. This view on the left side of your screen coming from the camera on one of Orion's solar arrays. Other conversation points while the crew are getting ready for their flyby today. They'll be looking to orient themselves using major landmarks and annotating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina. Thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
This is ARTEMIS Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with the floor, rings, and ejecta compared to a younger Oriental basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit-reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston Integrity, one report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing, because of course the Earth is much smaller than the moon in our view, so you could think that your eyes focus for the darker sky and that it means that it only has apparent brightness more than the moon, but since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room. Team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft. The crew is equipped with 80 to 400 millimeter zoom lenses. The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. Some of the things things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of raid craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit rep reminders.
We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off and are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Do you have any questions for us at this time?
We're very glad that you provided the first formal science sit rep at this. One follow-up question, any relationship between those browns and greens? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, I overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
The window team really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and then the bigger Mare off to the west, sorry, to the east was still dark, but maybe a 7. We still think that, but you are seeing color variation, albedo variation, Grimaldi as well, and that even on the west side there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to initiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis 2, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us for an interview.
Window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the t-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Babylon. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where Babylon has that impact over the top of another crater, where the 2 craters intersect on the eastern edge. So on the side closest to Oriental, where the 2 crater rings intersect, the shadow there is the highest peak in the interior of Babylon, and so you can see the real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the t-shirt shroud from window 1.
Yeah, absolutely. We will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, he is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from, he is on that support team, and he is tasked with providing the science sit reps. While the 2 crew photographing and making annotations of the moon are in Windows 2 and 3, Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by, but this is an animation. You also heard Glover mention Oriental. Oriental is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Oriental Basin had never been seen in sunlight by human eyes. Oriental Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to a Kennedy Space Center. This a live view in ARTEMIS Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been this team has been monitoring the entire time of have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website, that you can also access at any time by visiting nasa.gov/track-Artemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them off. There are a few LEDs that they cannot turn off, but turning down these lights by the spacecraft, bouncing up. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they see the moon and the Earth in the same view, and we're looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it. Those first blocks of teams will last about an hour, and the crew members are approaching the halfway point into their first observation block. A reminder, we have 5 of those blocks today. So they're approaching this halfway point in which the crew at the window will switch roles. One will begin taking pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means Pilot Victor Glover and...
Integrity, looking at window one, I think I may have misreported earlier, saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east. And that is now like on the horizon or just past it. And the Korolev is now a few degrees from going over the horizon. And then, next it'll be Aristarchus. Aristarchus is plateau. And so on the west, we are getting a much better view of the Terminator. It looks like we have about 80% illumination of the moon. And Vavilov and one Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental. And just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, just alpha, and darkest type high albedo. Interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and not dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And also is a lot of variation in albedo. And some of the features, for example, have on the southern edge of the line one, like the southern and western part of Grimaldi, to the north, closer to Glushko, is also that same dark albedo. And then around them there are some albedo spots, just the north of the lower, the southern one, and just to the west, the smaller one to the north, very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots just starting to pop up in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of very defined central peak that is also 3 in albedo, and all of that area past it going to the horizon gets lighter and